Very good evening to all of you. Welcome to our live classes on Ekeeda Private Limited, and today's our subject is Electrical Machine 2, and the topic which we are going to study today is equivalent circuit of transformer. Am I audible? Can anybody confirm whether I am audible to you all? Hari Harbi, very good evening. Tamina Lokesh, very good evening. Am I audible to all of you? Okay, thank you. Now, before going to the equivalent circuit of transformer, let us first try to understand the referred values. So, when we talk about transformer, we know that transformer has two windings, primary winding and secondary winding. So, in order to simplify the calculations of the transformer, you can draw a circuit which has only one winding with other winding referring to it. Like for example, you can have the equivalent circuit with primary referred to secondary, or you can have the equivalent circuit with secondary referred to primary. Now, by doing this type of arrangement, it becomes easier to do the calculations of the transformer. Okay. Now, Rohit Yadav, what you want to do? Machine first की class attend करनी है. Okay, so for machine 1, we have the class on every Saturday from 6 p.m. to 7 p.m. Okay, you can attend those classes. We have the classes for machine 1 every Saturday from 6 p.m. to 7 p.m. Also, if you want the detailed lectures, you can go to the Ekeeda website and there you can search the machine 1. You will get the detailed syllabus over there where there are already recorded videos. You can also try that. Okay. So before going to the equivalent circuit, let us study about the referred values. As I told you, in order to simplify the calculations, we can refer primary values to secondary, or we can refer the secondary values to primary. So the first point which we are going to study today is referred values. So what is the advantage of doing this type of referring values is that we have to work on only one winding. Working on two windings becomes very complicated. So when we refer primary values to the secondary values or secondary values to the primary values, we have to work on only single winding. So that is the advantage of doing the referred values. Now let us first try to understand the secondary values referred to primary side. Okay, so let us transfer first resistance. So let R2 dash be the value of resistance of secondary of your transformer. So I will write transformer in this way. Okay, this is the shortcut for transformer. Okay, you need the class routine. Okay, so every Sunday we have from 10 a.m. to 11 a.m. classes for electrical machine 3. That basically deals with 3-phase induction motor, single-phase induction motor. Then on every Thursday from 6 p.m. to 7 p.m. we have the class for conventional and non-conventional power generation. Then on every Saturday from 6 p.m. to 7 p.m. we have the class for electrical machine 1. Then on alternate Tuesday we have the class for electrical machine 2, 6 p.m. to 7 p.m. And on alternate Wednesday we have the class for protection and switchgear engineering from 6 p.m. to 7 p.m. I hope you have understood. Okay, so you can attend these classes, as well as if you want, you can go to our website, that is ekeeda.com, and on that website you can get the detailed lectures of all these subjects. They are already posted over there. Okay, so I am going to represent transformer in this way. It becomes easier. So R2 dash, let the R2 dash be the value of the secondary resistance of transformer which is transferred to the primary side. Transferred to primary. Now this resistance R2 dash that is reflected on the primary side, it will have the same effect as that of the resistance R2 which it would produce if it was at the secondary. Okay, so it is not going to change its effects even if we are referring it to the primary side. So it becomes very simple. Now because of this, whatever is the power that is consumed by R2 dash, when it is carrying the primary current, it will be same as the power it would have consumed when it would carry the secondary current. So because of this, we can write, hence, I2 dash square R2 is equal to I2 square R2. Okay. sorry, R2 dash. Why? Because we have transferred the resistance of the secondary to the primary side. That is what we are going to do. So when we are transferring this value of the resistance from secondary to primary, it is not going to change anything. It will have the same effect if it was present on the secondary side. Now from this, what can we do? So therefore, your R2 dash will be equal to, let us take this I2 dash square on this side. So what we will get, I2 divided by I2 dash whole square multiplied by R2. Okay. Now we know the transformation ratio of the transformer. So what is the transformation ratio of the transformer? But I2 T2 is equal to I2 dash into T1. Correct. Now if I take the ratio of I2 by I2 dash, then what will I get? Therefore, I2 divided by I2 dash, it will be equal to T1 divided by T2. And what is T1 divided by T2? T1 by T2 is our transformation ratio, which is denoted by K. So if I substitute this value of K in this equation of R2 dash, what will I get? Therefore, R2 dash is equal to K square into R2. Okay. So in this way, we have transferred the secondary resistance to the primary side. So let it be equation number 1. Now this was about the resistance. Similarly, we can also transfer the reactance. Okay, so let us transfer the reactance. Similarly, have you understood how we transferred the resistance? Is everybody clear what is R2? R2 is the resistance of secondary winding transferred to primary side. Okay. Now let us transfer the reactance. So similarly, let X2 dash be your reactance of secondary referred to primary side. Okay. Now again, when we are transferring the reactance X2 dash from secondary to primary, this X2 dash will produce the same effect to the primary side as if it was X2 in the secondary. What this means is that this X2 dash in the primary side should absorb the same volt amperes, that is VA, as if it was connected in the primary. So we can say that now VAR, that is your volt amperes, is equal to VI into sin theta. We know this is the formula. Okay. Therefore, also we know that V is equal to IZ, simple Ohm's law. So again, your sin theta is nothing but X divided by Z. So we know all these formulas beforehanded. So if I substitute all these values of voltage and sin theta in the equation of VAR, so what will I get? What is VAR? VAR is my reactive power. Okay. So VAR is equal to V is equal to IZ multiplied by I multiplied by X divided by Z. Okay. So if I substitute this, what will happen? This ZZ will get cancelled. And what will I get? VAR, that is my reactive power, is equal to I square multiplied by X. Now, if we want to equate the reactive power, that is your reactive volt ampere, by X2 dash to the X2, what we will get? As I have told you, it will not affect whether it is connected at secondary or it is connected at primary side. So we will get I2 dash square X2 dash is equal to I2 square into X2. Understood? Why? Because when we are transferring X2, that is the reactance of the secondary to the primary side, it has to consume the same volt ampere, that is it has to consume same reactive power as if it was connected at the secondary. That is why we have to equate these two values. Okay. Now after this, what we will do, I will take this I2 dash square on this side of equation. So what will I get? X2 dash is equal to I2 divided by I2 dash whole square multiplied by X2. Again, what is I2 divided by I2 dash? That is nothing but my turns ratio. So I2 divided by I2 dash is equal to T1 divided by T2. That is nothing but your K, right? So what will I get? Therefore, X2 dash is equal to K square into X2. Understood? Let this be equation number 2. So in this way, what we have done, we have found the formulas of the resistance of secondary to the primary side. Similarly, we have found the value for the reactance of secondary that is transferred to the primary side. Similarly, we can do for the impedance as well. Now, let Re1 be equal to effective resistance of whole transformer. Okay, now we are not going to talk just about primary or secondary winding. Let it be the effective resistance of whole transformer but referred to primary. Whole transformer referred to primary winding. Okay. Similarly, let Xe1 be the value of what will be Xe1? Effective reactance of whole transformer referred to secondary. Whole transformer referred to primary. Okay, we are talking about primary. Similarly, let Ze1 be the value of the effective impedance of whole transformer referred to primary. Referred to primary. Okay. Now when we talk about, yes Tarun Kumar, very good evening, welcome to our class. Now when we talk about Re1, that is your effective resistance of complete transformer referred to primary, obviously it will be addition of your primary resistance plus your secondary resistance which is transferred to the primary. So how can I write the equation? Therefore, Re1 is equal to primary resistance, primary winding resistance plus secondary resistance which is transferred to primary. Yes Manoj, very good evening, welcome to our online class, plus your secondary resistance which is referred to primary. Correct? Your total effective reactance resistance will be addition of these two resistances referred to primary. Now let us write the formula. So what will I write? Therefore, Re1 is equal to R1 plus R2 dash. And the formula for R2 dash we have already derived in equation number 1. Therefore, from equation 1, let us substitute in this equation. What will I get? Therefore, Re1 is equal to R1 plus K square into R2. Okay, this is the formula of my effective resistance of the whole transformer but referred to primary side. Let it be equation number 3. Now this was about resistance. Similarly, we can calculate effective reactance. What will be your effective reactance? Xe1 will be equal to X1 plus X2 dash. Again, we have calculated the formula for X2 dash from equation number 2. So when we substitute in this equation, what will we get? Therefore, Xe1 is equal to X1 plus K square into X2. So this is the formula for my equivalent reactance of whole transformer referred to primary side. Now we know the value of the resistance, we know the value of the reactance. We can easily find the value of the impedance. So how we will find the impedance? Therefore, impedance Ze1 will again be equal to Z1 plus Z2 dash. So again we will get, therefore, Ze1 is equal to Z1 plus K square Z2. This is the formula for your equivalent impedance or effective impedance of the whole transformer but referred to primary side. Okay. Now we can also write the formula for the impedance in terms of your resistance and reactance. We all know that formula. Also we can write it as Ze1 is equal to Re1 whole square plus Xe1 whole square under root, or we can also write it as Ze1 is equal to Re1 plus jXe1. Let it be completely equation number 6. So what we have done over here, we have transferred the resistance and reactance of the secondary side to the primary side, and by doing that we have found the value of the equivalent resistance, or we can also call it as effective resistance of the primary, that is nothing but the primary winding resistance plus secondary winding resistance referred to primary. And what is its formula? Re1 is equal to R1 plus K square R2. Similarly, we have also found the value of the effective equivalent reactance of the whole transformer, but again referred to the primary side. What is its value? X1 plus K square X2. Similarly, we have also found the impedance. So in this way, we have transformed all the values of the secondary side to the primary side. Is everybody clear with this? Does anybody have any doubt? Just let me know. If anybody has any doubt, just let me know. Has everybody understood how we have transformed the values? Similarly, we can also transform the value of the load impedance. Okay. So the load impedance, again referred to primary. How can we write it? Simple. Again, we have to multiply it by K square. So K square into ZL. So this was all about, yes. Okay. Now let us start with our referred to secondary values. Now what we have done, we have referred all our secondary values to the primary side. Now we are going to refer all our primary side to the secondary side. Okay. So let us start. Equivalent values referred to secondary. So we have to follow the same procedure. Okay. Only what will change? Who will tell me what is the transformation ratio? Who will tell me what is the transformation ratio for transformer? Can anybody write it in the chat? What is the transformation ratio of the transformer? Yes, anybody? Anybody? What is the transformation ratio of the transformer? It is very simple. We have studied it in our previous class. Yes, anybody? It is V1 by V2 is equal to T1 by T2 is equal to I2 by I1 is equal to K. Correct? Yes or no? Now, if we want to transfer the values to the secondary, obviously we have to make this T2 by T1. Correct? So it will become 1 upon K. So let us see how we are going to transform. So your equivalent circuit. Okay, Arjun K, very good. Yes, Shantanu, what you can do is you can watch the video again and then practice it. It is not that hard. It is very simple. We have just transformed the values. Okay. Yes. Now let us do it. So let RE2. Now what is RE2? Initially RE1 was the value of your effective resistance of the whole transformer referred to primary. Now we are going to secondary. Okay. So RE2 is the value of equivalent resistance of whole transformer referred to which side now? Referred to which side? Referred to secondary side.